Okay, we've determined the row space and the null space corresponding to any matrix that reduces to this. Okay? We build a matrix. Okay? Now the only thing you can do is add multiples of rows to rows and multiply a row by a number. So really, I just multiplied this row by -3 to get this, and of course added it to the 0, 0, 0. And I multiplied this row by 1/4 and added it to the third row to get this. So here is a matrix. It's the one I built. Everybody else built matrices that had similar characteristics. In this matrix, it isn't quite reduced to the point where we have a leading one, but one more step, dividing this row by 4, would give us a leading one here, okay? And that's in the second column, meaning that the second column of this matrix is going to be the basis for our column space. Okay, now, if this is a mapping, okay, if we define a mapping T from V to W, and I didn't really write the definition of that mapping because everybody had it on a piece of paper, but the definition of the mapping is just T applied to V is just A multiplied by V. Okay, so our transformation is just defined as a transformation defined by this matrix. Okay? And I think I used the word define too many times there, but you understand what I mean. Now, when we do that, we're going to find that our column space is in W. It's over here. Okay? Now, the column space for this matrix is spanned by just a single vector, 4, -12, 1, meaning we go 4 units in this direction, -12 units in this direction, and just 1 unit in this direction, okay? So, you know, that's going to give us a vector out here, but then the -12 in this direction is going to really turn that around here and then up 1. This is the direction of our column space. Remember that the direction of our row space was somewhat different, okay? It was parallel to the vector 0, 4, 1, okay? And that would be a vector out about here. So here's the direction of the row space, here's the direction of the column space. Now, that's not a problem. The column space is in W, okay? This column appears in the set of vectors that you get when you multiply vectors in V by the matrix A, when you transform a vector in V, okay? Well, if you transform the vector 0, 1, 0, you can verify that multiplying that matrix by 0, 1, 0 is going to give us 4, -12, 1. So it's over there in the column space. Then, of course, we've done, you know, you've seen videos depicting how this works out. Now, there are problems you're asked to do with this, okay? Pick a vector in the row space and see where it goes in the column space and get an idea of how the transformation works.